Yes. Trying to figure out the whole client, right? Um, Clients might come to you with physical looking things. If you see that, you might want to get a medical diagnosis for that, right? For us, we're all about the brain, just like a neuro doctor, but we want to assess and look and observe and figure out this whole person, become investigators of a person to make sure we get everything we need to provide the best care for this person, right? So assessments and testing, that's part of it for diagnosing, like I heard, for diagnosing, for um, accurate measurements, rating scales. I mean, a person can come and say they feel X, Y, and Z. I'm like, okay, well, here, take this Beck depression test and let me see how much. You need something to go off, right? So measurements is general process of determining the dimensions of an attribute or trait. Assessments, when you're doing assessments, it's a difference between assessments and appraisals. Okay? Assessments is processes and procedures for collecting information about a human behavior, right? Assessment tools include tests, inventories, rating scales, observation, interview data, and other techniques. Highlight that, please. Now, when we talk about appraisals, what's an appraisal? Just generally speaking, what's an appraisal? Has anybody got an appraisal on their job from their boss or something?
It's like a performance.
Like your performance,
Hmm.
exactly. And that's exactly what it is. It is an appraisal that implies going beyond measurement. So this, you're going to want to look for this keyword attributes. Okay? Highlight that. So you're making judgments about the human attributes and behaviors, and it's used interchangeably with evaluations. So if there's any educators on here, I always go back to that because that's kind of all I know. When the principal comes in and sitting there for 45 minutes and watching you teach, watching you give instructions, watching you and your students' interaction, watching your classroom behaviorment style, watching how you got the walls, they are giving you an appraisal. At the end, they're going to rate each part. Either you're proficient or you're upcoming. That's what an appraisal is. We're technically literally just watching the client and marking it down. Then interpretation, making a statement about the meaning of usefulness of the measurement data according to the professional counselor's knowledge and judgment. Okay? I would highlight meaning or usefulness of measurement data. Because at this point on the NCE, it's a whole bunch of definitions. And for the definitions, you would have to just know the terms. So that's why we're highlighting parts of the definition and pulling out keywords that will bring you to that word. Like for instance, for appraisal, attributes and behaviors. What is the measures of central tendency? Somebody explain it to me, please.
That's your mean, median, and mode. Those are like the main things of like the the distrib like of the scores. Like so of like how you get them. Like for instance, like the mean, you like so if I got six numbers, um six numbers, you add them and then you divide
Do
by.
we add them or we got to do something before we add them?
Oh, you
So,
what?
uh,
Put them in order.
Put them
put
in
them in
order.
order from least to greatest, right? So we're gonna find the mean. We're gonna put it's gonna be a whole. Think about just grades. It's a 54, are it's a 64, it's a 23, it's a 33, and they scattered. We're gonna put them all in order from lowest to highest. Okay.
And you
Now
do that for
remember,
the median as well, right?
for the median as well. Yep. Yep. For the mean, what we're gonna do? So once they all in order, we're gonna add them all up. Once you get that average of it being added all up, you're going to do
Divide.
what?
Divide by the numbers that
Divide by
you
the
have.
number of the
Divide by
scores.
the number of scores that you have, and you find your mean, right? For the median, and for mean, I want you to highlight arithmetic average. That is the average. And also remember the mean guy is in charge, all right? For median, that is what's a median on the street, in the middle, straight up in the middle. So what's gonna happen? You're gonna order your numbers from from lowest to highest, and then you're gonna take your finger, because that's how I do it, and you just keep blocking off numbers till you get to that middle number. You get to that middle number, that is your median. Okay? Then there's a mode. What is the mode?
That's the most frequent number that's in your set of numbers, right?
That's the most. Okay? That's the most you're gonna see. You might see a 5, 5, 1, 2, 3, 6. You've seen 5 more than once, that's gonna be your mode. All right? Highlight all 3 of these fall in the same place when distribution of scores is symmetrical, and that is a normal distribution. So they are all equal on the bell curve. Everybody, we good? And then there's skew, okay? Skew just means they did not all line up equally on the bell curve. All right. So when that does not happen, we have a positive skew and a negative skew. Okay. It is very important to remember the mean guy is still in charge, but the mode will always be on top. Like Dr. Pam said, ice cream a la mode. The ice cream is on top of the mold every single time, right? So there you go. I hope my computer don't start acting crazy. Am I okay? Y'all hear me?
Britt, I guess how I remember that is the tail to the right is positive, the tail to the left is negative. Have you seen it
I
like
was
that?
getting there. Oh yeah, I was taking it a little slow. I was going. She is absolutely right. So when you are this on the normal bell curve, you know when you're plotting, you have your mean that is 0. To the right, you have your plus 1.0 plus 2.0 plus 3.0. Anything to the right is positive. So positive skew, the tail is going to the right. It is positive. All right. Now we plotted the positive side. Let's plot the negative side. Negative 1.0, negative 2.0, negative 3.0. The tail is going to the left. It is a negative skew. Okay. I would highlight what I just said. The relationship between mean, median, mode are indicative, indicated above the above for skewed distributions. Highlight the mode is at the top of the curve, which is most frequent score. The median is in the middle, and the mean is what is pulling your tail where it needs to go. Okay? Everybody good? We're following? I guess that means yes. Why?
Yes.
Okay.
So basically, we're looking
Next,
for which way the mean is pointing, and it lets us know the tail.
the mean will
Okay.
determine where that tail is going.
Tail.
Wherever the tail is heading, that's how you know if it's positive or negative.
Negative. Gotcha.
Mhm. And we know positive and negative from a number line, one,
Mhm.
and from just plotting on a normal bell curve, right?
Yes.
All righty. Measures of variability. Then there's the range. How do we find the range?
The highest number minus the lowest number.
Yep. And how would you write it to remember it?
Like the example, 47 minus 24 equals 23.
Mm-hmm. So if you see how she got that, this is the example, these are the ages, right? And they're already in order, so we don't have to put them in order. You see how they're in order from least to the highest? So when you're looking for the range, you're gonna take the highest minus the lowest, and that's gonna give you your range. Okay? So what is it? I want you to say it to me.
The highest minus the
Highest
lowest
minus the lowest,
Equals the what?
range.
the range.
Equals the range. Yes. 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 Now, they might ask for an inclusive range. What is
It's your answer plus one.
hallelujah? Yes. Yes and yes. So you got the highest minus the lowest equal the range. For an inclusive range, I'm going to add one. Okay? Deal. Standard deviation. What is the standard deviation before I say it? Anybody know?
Is it 0.05? No, that's like the p-value, right?
That's the probability. Yep. What is standard deviation? What's the definition of a standard deviation? The standard deviation is just saying how far apart the scores are on the plotted line. It's the variability of how far your distribute scores are on the bell curve line. Now, standard deviation has a sign, okay, and it's called the sigma. And this is the sign for standard deviation. So I want you to see that and know that. That is the symbol for standard deviation. Standard deviation is essentially the mean of all the, oh, excuse me. Oh, excuse me. Sorry, y'all. The deviations from the mean. So when you see variance, this is simply the square of standard deviation. I like to say variance is standard deviation complicated cousin. Does the same exact thing. However, it is the squared, not squared root, the squared of the standard deviation. So you'll see standard deviation 2. That's all you need to know. We don't have to know how to calculate it. We don't have to know how to do it. Just know that it's the square of standard deviation. It is standard deviation complicated cousin. Does the same thing, came from the same family, but she do a lot. She do too much. Okay. The normal bell curve. All right. So on the normal bell curve, it essentially distributes the scores to 6 equal parts. Why did I say 6 equal parts?
Because on the bell curve, the numbers for your right side and your left side are gonna be like the same disbursement.
Mm-hmm.
So you got And it's gonna equal, that's what's gonna equal the percentage, that final percentage, if that makes sense.
Yep.
So
Come
I
on,
got,
And
three
even
above the mean.
easier. What'd you say?
Oh, I said three above the mean, three below the mean.
3 above the mean, 3 below the mean. Remember, we plotted positive 1.3, positive 2 point, I'm sorry, positive 1.0, positive 2.0, positive 3.0. I'm going to the left now, negative. Negative 1.0, negative 2.0, negative 3.0. Now let me show you. You see that? Remember, this sign is standard deviation, but your standard deviation is also z-scores. So look at that. 1, 2, 3. Don't worry about the 4. 3. 1, 2, 3. Totaling together 6 equal parts. Got it? Commit to memory. What is the empirical rule? Tell me. What's
It's the
the empirical rule? I'm calling the name of what it is so you know when it's a definition you know.
Is it the 68, 95, or 96 and 99?
There you go. That is the empirical rule. 68%, 95%, 99%, 99.7, but 99%. And sometimes you'll see 96%, but it's the one in the middle, okay? How do we get it? 34 plus 34, well, 34% plus 34% give you 68%. 34% plus and or plus 34% plus 13.5% plus 13.5% give us 95%. And all of those plus these give us this. Everybody got that?
Yes.
All that is saying is, once we get here, I don't know why my computer is moving like this. The plus or minus 1 standard deviation, which is right here to right here, is going to be 68%. Plus or minus 2 standard deviations would be from here to here. Plus or minus 3 deviations would be from here to here. And that's all that means. Okay?
Can you repeat that?
Everybody?
Can you repeat that?
So 34.13% plus 34.13% equals 68%. Right here. This is 68%. 34.13%, 34.13% plus 13.59% plus 13.59% would be 2 standard deviations. That is now 95%. Adding all of those up and also adding 2.4% and 2.4% would be 3 standard deviations above the mean, and that would be your 99.7%. All that means is once you do that and you know that, and they start asking about kids are giving you what the mean is, and then telling you how much standard deviations you have to go to the right, you would know who would fall in between standard deviation 1 or 2 standard deviations above the mean, 3 standard deviations above the mean. But you have to know this empirical rule in order to get the correct answer about those things. Okay?
So Britt, they all on the test, they always gonna give us that what standard deviation they want us to do. Like, or no?
They always give you the mean, right? From
They don't,
practices,
okay,
they always would give you the mean and the standard deviation. You would
okay,
have to plot it and know how to do it. So if
okay.
I have a mean of 10 and a standard deviation of 2, how am I going to plot it? Anybody tell me.
Will
My
it be
mean will be 10
10 right here?
and I'm going to have a standard deviation of 2.
So it would be
The,
positive 2 on each on the right and then negative 2 on the left. So it would be 12 and 8. Is that what you're saying? Like
Yep,
the numbers
yep,
up?
yep, yep,
12, 14, 16,
yep,
8,
yep,
8, 6, and
yep,
4 on
yep.
the
That's exactly what I'm saying. Everybody see how she did it, how we got it?
no,
no.
I lost traffic.
Me too.
I lost
So
traffic. I'm sorry. Joy,
Yes,
could you say that one more time?
sure.
Okay.
So if the mean is 10, right? And
Hmm.
this and the standard deviation is 2. So that means the number that's separating the, to the right and left would be either going up positively 2 or down negatively 2. So it's, let's say right where it says test score, you have 10. To the right of it, what would be 2 more? Because that would be going up positive on the line,
Oh, so 12,
12. And then what would the next plot be?
+2.
14,
14. And
Uh-huh.
what would the next one be?
16.
All right, now
There
let's
you
go
go.
back to the 10.
Okay.
So if we're going down negatively, what would it
So
be?
8,
Yep. And
and
then,
then 6,
mm-hmm.
and then 4.
There
Yep.
you go. Now you have all of your plots on the standard deviation. Now you can go and answer every question there is. Because
Okay.
what you gonna do? All you do, whatever question they ask you, you look for that number and you gonna just go down. Even if they're asking for the T-score, if they're asking for the Z-score, if they're asking for the stanine, all you do is just take your finger and go down to where the answer is. That's the easiest way to do standard deviation. And to
Okay.
me,
Thank you.
yes. Now remember T-score. What is the mean of a T-score?
Is it 50?
50. Hallelujah. And what would the standard deviation be of a T-score?
10.
There you go. You got it. You got it.
So,
So
Brittany, if
then,
they ask for the T score, I know
mm-hmm,
on the test, I don't think I had that question, but if they ask for the T score and the mean is already at 50,
mm-hmm.
um, you're just gonna go up 10 from
You,
whatever they give you, or
if you know how to just draw out the Z-score, T-score, and that standard deviation, you're just gonna take your finger and slide down. I promise you.
okay, okay,
Mm-hmm.
okay.
Can
T
you
for
just do
10.
one just to show us?
I don't know how to draw on here, and I don't have. If anybody can pull up the bell curve where I can type in, I would definitely do it.
So,
But I'm not good at the drawing. And
okay, so we at 50. And did she say that what else did she say with the
well,
problem?
first you would have. So first we would. Let me see if I can pull up practice questions because first you would
Okay.
have to have the mean, which they give you the mean, and you would have to know what the standard deviation is. They'll give you that too.
Okay.
Once you know that, you know how to plot. If you plotted on that first standard deviation line, everything else is already plotted if you know how to draw the Z-score line and the T-score line. I would even try to draw the stanine line. If you know how to do that, then when whatever question they're asking about a number, you just go to it in the number line and draw your finger down and get the answer from whichever they're asking.
Okay.
All right.
For
So
an
basically
example,
put that on the dry erase board.
yes, yes, I would get there and draw this first. These are this in the research. I would learn those little things in research because those are the points that can get you over. I've been watching people who've been putting up their scores and missed it by 1 point, but they got 0 research questions right. And those are the scores that can get you all the way over.
Brittany,
Uh,
I just posted a video where they explain from Dr. Pam how to do it if somebody
okay.
needs.
Y'all see it in the chat?
Yes.
I would take that down. I'm gonna have to figure out a way. I know it's a way you can have one where you can type it all in and it's even better, but I don't have it. Okay, so we a little okay with that. We'll do some practice questions with that on my computer. Hold on, let me stop sharing and try to share again. So my computer is moving too slow for me. Okay, this might be a little better. All right, we there? Percentile and stanines, okay? This is what I need you to highlight. Percentile is a value below which a specified percentage of cases fall, okay? Highlight under stanine that 1 to 9 with 5 in the middle and a standard deviation of about 2. Highlight that. That is the definition of what a stanine is. Okay? Standardized scores. A standardized score scale is like common language, okay? You are first going to get scores or test grades, I can say, that are raw, which mean it is uncooked. That mean it has not been touched, right? Because you get them they're so raw, we can't do anything with them until we plot them and change them into a arithmetic kind of looking thing, right? So a standard score scale is like common language that we can use to compare several different test scores. Look at the example. A person has a raw score. Raw score literally means this is what they scored. Nobody touched it. There's no extra credit on it. It's not something that made it go up. This is exactly what they scored, right? Raw score of 60 on a vocabulary test and a raw score of 45 on an arithmetic test. Which performance is better? We can't say. It's raw. So we would have to do it to where we can get a percentage of what they did, right? So highlight standardized scores occur by converting raw scores distributions. We're looking at definitions when we're looking at assessments, not really doing math problems, if that makes sense. Hold on, Yama. Thank you. I love you. Good night. Okay. Where am I? Okay. Specifically, standard scores express the person's distance from the mean in terms of the standard deviation. Highlight that. The standard scores are your Z-scores and your T-scores. There you go. Now, remember when I said you're going to plot the scores on a standard deviation? Well, we can't plot raw and uncooked scores, okay? The only way we can do that is changing them into one of these. So Z for 0, what is the mean for a Z-score?
0.
0. And the standard deviation of?
0.1. I mean 1.0. Yeah.
The Z-score is the standard deviation. Just like how we plot 0 plus 1.0 plus 2.0 plus 3.0. minus 1.0, minus 2.0, minus 3.0, that is also your z-scores. Okay, so that's 2 that you plotted and it's already on there. Now, the z, oh my God, the z should remind you of 0. Then there's t-scores. What is the mean for a t-score?
50.
50 and standard deviation of
10.
10. So if you plot 50 down as your mean right in the middle, to the right, the standard deviation is 10. So what's going to be to my right? What am I
Uh,
plotting?
60.
90. Huh?
If my mean is 50, I'm going to my right. My standard deviation is 10. What's my first plot?
60.
60. I'm
Uh-huh.
sorry.
What's my next one?
70,
70.
What's my next one?
80.
80.
Okay, now let's go to the left, which is negative. If my mean is 50, what's my first standard deviation of a
40,
t-score?
40.
And then what's the next one?
30,
30.
And what's the next one?
20.
20.
There you go. You just wrote and plotted out everything on a normal bell curve standard deviation. Easier than what you think, I promise.
Can you just give us our NCE test?
Right now while we know, right? Let's hurry up and get it over. Then there's correlation coefficient. Somebody tell me something about it.
Um, it's the relationship. Like it just shows like the relation
Yes.
between your
Yes.
numbers.
I love using the relationship to talk about correlation coefficient because in order to figure that out, you have to use the Pearson product moment correlation, which is an aura. Relationship. That's how you're gonna always remember that as correlation coefficient. Relationships. And I heard on a video from a tutor, you will remember that it's Pearson product moment because Pearson is who we're taking our test with. So a correlation coefficient range from negative 1.00 to positive 1.0. Okay? That is correlation coefficient. Correlation does not cause causation. Okay? You do not get a cause. Something like the relationship is not going to be because something caused something, not with correlation coefficient. It's literally going to be the relationship. If it's hot outside during the summer and ice cream sales go up, there's a positive correlation because they're both going up. Okay? Now, if it's hot outside for the summer and hairspray is going up, that is a negative correlation because they both are not on the same page. It's no relationship. Okay? Now, there's a correlation between two variables, and that is called a bivariant. Yep. Remember, bi means two. That just means it's two variables. Bivariant. And when there's three or more variables, we're going to call it a multivariate. Highlight it, please.
So, question, it may be too far off though, but how do we like necessarily know the difference between like the two variables being bivariate and multivariate versus the ANOVA and stuff like that when it comes to like
Well, yeah, but the ANOVA in like the ANOVA for a fact would be more in your research part. But yes, ANOVA, you'll be talking about independent variables, right? Correlation, you're just talking about variables as if the relationship of what's being correlated. Does that make sense?
yes.
Yes. So if it's anything to do with correlation, because there is a correlation kind of design, just to see what and what is being have a good relationship. Like for an example, what I said, if during the summertime the price of ice cream sales rises, then we know that that is a positive correlation because they're both going up. But when it's not one going up and one going down is a negative correlation or don't, and then it goes like this, then we don't gotta hear about it. Now, bivariant is two variables, maybe ice cream and sunscreen, or two things that's going together, then it's a bivariant. I think just knowing this definition is all we really need to know of what two variables, when we're talking about correlation coefficient, what is it called? Bivariant. If it's multiple, three or more, then it's called multivariant. In the case of ANOVA, that's three or more, then that's a ANOVA. Two tests, t-test. Multiples, then, and CANOVA and all of that. And F factor, but I'll do research and we'll get it, I promise. Remember, it's not a cause and effect deal. Make sure you highlight this. Right? Now we're getting into reliability. What do you know about reliability?
That a test can be reliable but still not be valid.
Mm-hmm. When I think of reliability, the one word I'm always going to look for is consistency. A test can be reliable. It can be consistent. It can be consistently wrong, but it's going to be consistent, right? A child in the classroom, he gonna act up. It's not what I want him to do, but he's gonna be consistent in acting up every single day. Okay. So every time I look for anything with reliability, I'm gonna look for consistency. I'm gonna look for the word consistent. I'm gonna look for the word over and over again, anything like that. Okay. So it consistently, reliability is the consistency of a test or a measure. Is it consistent? Is it going to produce every single time? Now, just because it's consistent doesn't make it valid. It doesn't make it good. And in order for anything to be great, it have to be reliable and valid. That is the most important thing. It needs those two things, okay? Reliability can be viewed as the extent to which the measure is free from error. Okay. Also, in research, if the reliability of coefficient is high at about 0.70 or higher, the test scores have little to no error. In research in our field, the lowest we will go and we will take is 0.70. Nothing low, not a 0.60. We're not taking that. That's showing that it's going to be too many errors. Now, when you talk about probability, 0.5 is where we're going, and then we're going lower, either 0.01 or 0.001. But here with coefficient reliability, we're talking about coefficient, correlation coefficient. We're only going to take 0.70. Jazz, what they say? Is she on here? Jasmine?
Yeah, I'm here.
What it say for 70?
It has to be 0.70 or higher.
No,
C's,
how we remember it? What you say?
C's for degrees. You want to get a 70
C's
or
for
higher?
degrees. A C will get you a degree. 70 or higher. Remember that. C's for degrees. Also highlight reliability is a necessary psychometric property of test and measurement. My computer is not doing right. I'm sick of it. All right. Why is it doing that? I don't like it. Now types of reliability. Here we are. So I know. I've seen it different to remember, and I've seen it different too. However, I was doing some study questions and it came out to be like this. I know on some things you'll have reliability and you'll just have test, retest, split half, all of the things that's underneath reliability, right? Here, you want to note stability is test, retest. Okay? That just means reliability obtained using the same instrument on both occasions, same group tested twice, is going to be a test retest. Okay? Then you're going to highlight, in order to do that, you have to wait 2 weeks to go ahead and administer that other test. Okay, test retest just mean somebody took a test. We want to make sure that the answers are consistent. We're going to give them another test. Test retest. That's all. We're going to wait 2 weeks and give them the same test, the same group. We're going to give it to them twice. Test retest to see if the reliability is going to show up again and again. All right? Everybody got that? Equivalence. Alternate forms. You may also have heard parallel forms, form A, form B, right? Parallel forms is basically what the NC is. I might get form A. Tiffany might get form B. Somebody else might get, it's just parallel, is right there on the side. But what you're looking at to see the equivalence of both of those parallel tests, I'm going to just say form A and form B, parallel tests, right? Alternate forms of the same test. It don't look like I had the same test, but I did. Mine was form A, yours was form B. I don't know if you remember in school, the teacher thought she was smart. Everybody who sat next to each other had a different form, so we couldn't cheat. That's all it is. Okay. Internal consistency. Now you see split half method, right? The split half method is the correlation between two halves is calculated. You're literally taking the test in half and looking to see what's the correlation of these two halves. All right? Because you reduce length of the test, 1/2 versus 1/2. Highlight. You may apply the Spearman-Brown formula to test this hypothesis. Okay, don't say hypothesis, but to test this prophecy. We're using the Spearman-Brown formula to see how reliable the test would be had you not split in two. All you need to know, a split half means I'm splitting the test in two. That's it. If you see a question saying, what method is being used when a test have to be split? Bam, a split half method. What test is it when it's a form A and a form B? Bam, parallel forms, equivalency. What does it mean when a group get the same test twice within 2 weeks? Test retest. Okay, that's how you need to know them. That's why I'm saying highlight. And then you also going to use the computer Richardson forms. That just means it's dichotomous. That just means that it's a true and false test. Okay. The next one right here, the Kornbach, that means it's multiple tests. Highlight at the bottom, all of that. 2, dichotomous, that's when you're going to use your Cuter Richardsons, okay? Multiples, multiple choice essays, that's when you're going to use the Kornbach, or however you say that. I'm messing these people's name up so bad.
It's
There
Cromback
you go.
and Cooter Richardson.
Kromback. My muscles and my tongue is not made to say it like that.
You
And
are
if
fine.
anybody from New Orleans know exactly what I'm talking about. Our tongue is made very lazy. It's the muscle. All right, here we go. Y'all ready for this? True and error variance. Highlight it, please. Okay, so what this is saying, just hear me out, because I had to watch, I had to listen to get it, but I promise I got you. So first, this test measures true and error variance, okay? You want to measure true variance, the actual psychological trait or characteristics that the test is measuring, okay? All that is saying is, look at the example. 2 tests are administered. Each one measures true variance, T1, and T2, and error variance, E1 and E2, okay? If the correlation between 2 tests or 2 forms of the test is, for an example, 0.90, then the amount of true variance measured in common is correlation squared. All right, hear me out. Here, coefficient of determination. They gave us 0.9 squared. So all we're going to do is take 0.90 times 0.90, right? What do that give me? Somebody calculate it.
Is that 81? Wait.
It's
81.
81. There you go. Yes, thank you. That is the coefficient of determination. Bam, that's your answer. Now we're going to take 81. Am I? Yes. Now we're going to take 81 minus that by 100. What does that give me?
$19, right? 19.
There you go. That's your coefficient of non-determinants. That's how you do that. Okay?
Is this
You wanna
something we have to be able to calculate? I never seen this on
just in
there.
case you do, you know, my love. Look, it's gonna be squared. All you're doing is multiplying by 2.
Okay.
I think we can do 2. I can't now. When you start getting to 8 and 10 and 12, you lost me by hand. Okay? 2. I can do 2. That's all you're doing. You're taking a number they're gonna give you, and it's gonna be squared, and you're gonna take that and just multiply it. All right? You're gonna get the answer from what the multiplication thing give you. You're gonna take the answer and subtract it by 100 because that's total percentage, right? And that's all you're doing. That's it. That's all. Okay? We're good? Can somebody explain standard error of measurement for me? I can give it to you real easy.
Is that the
But
bell curve? Like, is that the
it will
normal?
be on the bell curve, yes. So if we highlight the definition so you know. Standard error of measurement is another measure of reliability and useful in interpreting test scores of an individual, okay? It helps determine the range within which an individual test score probably falls, okay? So a person scores a 92 on the test, okay? The test standard error of measurement would be 5.0, okay? Chances are about 2 in 3, 67%, that person's score falls between 87 and 97. Okay? So we will refer to the normal curve, which is 34% and 34%. What is that? 34% and 34% is what standard deviation
The
of
68. The
Deviation.
first, yeah, 68.
one standard deviation
One
above
standard
the
deviation
mean.
above the mean.
Yes. So our score is 92. Where are we putting 92? On the mean, right in the middle. We're taking 92 and putting it where the
Oh,
zero is. All
okay.
right. Now, the standard error of measurement was 5. So what am I about to do to that 92? I'm about to
You-
plot it on the right and I'm going to
Plot it
plot
on
it
the
on the
left.
left. So my standard error of measurement is 5. So what that 92 is going to be when I start on the right?
97.
Now if I do it on the left, what is going to be?
80,
92 minus 5.
86, is it? Oh.
87.
87, there you go.
87. Okay. Now, when we talk about standard error measurements, that would be the number there. Now let's start with the person. So for the same test, the same error measurement is 5, you can say that 95% of the time the person scored will fall within the range of 82. So we took, let me get my 92. All you're doing is plus or minus in what the standard error measurement is to what you already have. And that's going to give you, oh, we got it right here. 1 second. Okay. All right. Now, we got the 87 on that side, and you said 97, right? Now, let's do another standard deviation. When you plus 7 to this 97, what is it going to give you? I mean, when you plus 5
Plus
to the
5, right?
97. Uh-huh.
102? Is it
There you
102?
go. You see 102 here? Now, when you do it the same thing to the 87, go one more time. What is it going to be?
82.
82. That is in the 95%. That's your standard error of measurement.
Hmm.
That's
I've had
it.
several questions on this test that say that, and I did not know what they was doing talking about.
Adding 5 to the numbers you already have. Like if they saying that it's gonna be 95%, we know that's 2 standard deviations above the mean. So we're gonna do that twice, right? If it's 1 standard deviation above the mean, we did it. It was 97, 87. But what did we do? We took that raw score of 92,
Uh,
added the standard error measurement, which was plus 5 to it, and we plotted it. The first standard deviation, that first one, we got the 87 and the 97. But they said 95%, so we know that's going to be the second one. So we got to do it again. So basically you did 10 instead of 5 because we had to do it twice. Do you get it?
And so it's gonna ask for whether it was, will we know whether we needed to give the positive second deviation or the negative?
What you do to the left, you got to do to the right.
Okay.
That's like in math, period. What you do to one side, you got to
Okay.
do to the other.
So it would
Yeah.
say the range is between 82 and 102.
It probably would just give you these answers, the numbers, and you have to pick which one would be the right one, given 95% of the time a person would score between the range of like that. If it say
and they'll give you the range,
68%,
like 82 and 10, like the different
like
range.
they'll give, and you would have to pick which one is the right
Yeah.
range.
Okay. Yeah. Okay.
Yeah. So everybody gets standard area measurement. You're just adding whatever number they're going to give you the standard area error of measurement. You have to know how to calculate it to whatever that empirical rule. It'll say 95%. We know we have to do 2 standard deviations. If they say 68%, we'll have to do 1 standard
Fine.
deviation.
Okay.
If
Yeah.
they say 99.7, we're going to do 3 standard deviations. So we would have took that 102 and plus 5 again.
Yeah.
Right.
We
Okay.
would have took that 82 and minus 5 again. And then that would have gave us the answer for 99.7%. Get it?
I think
That
the thing that
makes
I
so much
didn't
sense.
realize,
Jeez, that makes so much
yeah, I think the thing that I didn't realize is like for a question like this, like how to
Mm-hmm.
plot it, like that the
Mm-hmm.
92 was the mean, like for that. And then just now
Yep.
that's easy. That's super easy now. Like, well,
Yeah,
for,
because
like, but I didn't realize that you just put that. I guess I was looking for the mean.
the
Because
mean is the
other questions
average.
it'll say the mean. Okay,
Yep.
so when it's this way, just put
Yeah.
that, plot it that way,
Right. Just
and then
plot
go
it
over.
there. I'm
Yep.
telling you, these are the points that'll get you over. You just
I
have to
never
do
thought
them.
this part of the test would be the test that could get me good points. I really
This a
like,
big
yeah,
part.
yeah,
So
yeah.
everybody get it?
Yes. Thank you.
Yes,
Yes. Thank you.
good. You're welcome, welcome, welcome. Trust me, when I got it, I was like, that's it. I was like, okay, I can do that.
It
But you
this
have to commit to knowing that rule. If you don't know the rule, then you wouldn't get it. If you didn't know
either.
that 68% wasn't one standard deviation above the mean, you
Hmm.
wouldn't get it. If you didn't know 95% was 2 standard deviations, you see how we did that? You wouldn't get it.
That's one of the first things I went in there and wrote on. I did good on this section, but I didn't know this
Hmm
right here. That's one of the first things I went and wrote on the blackboard. Cause I mean on the
hmm
whiteboard. Yeah.
If you know how to just plot the standard deviation, z-score, which is the standard deviation, and t-score, you can kill it. Because they're
Mm,
going to give you what it is. You just going to have to keep 1, 2, 3, 1, 2, 3. And that's all.
mm.
So, validity. Gotta have validity. Or the test ain't worth nothing. So, validity is degree to which the test measures what it purports to measure. Is this what is supposed to be giving me? Highlight that, please. Then they have types of validity. Toya always say F Cocoa Krispies, and if she so graciously will put it in the chat because she put the split in there, and we'll have her explain what that means when we're finished. It's a great memory device. So first you got face validity, literally appearance, face, what it look like. Does it look like what it's supposed to be? Okay. Do our Holy Bible look like a Holy Bible when we hold it up? If I hold it up, do you know it's a Bible? Yes? Bam. That's it. Face validity, does it look like what I'm about to take? Content. Look, here's an example. A math test have math items, period. Content. Highlight. Instrument contains items drawn from the domain. Content validity is what's inside the book when I open it. When I open my Bible, do I see scriptures? Or do I see song? Well, it's songs in there too. Do I see a whole bunch of scribble
Math problems.
math problems? There you go. Thank you. So, for an example, two professors of Psychology 101 devised a final exam which covers the important content that they both teach. Content, what's in there? Then there's predictive, okay? Predictive, the predictions made by the test are confirmed by later behavior. For an example, the scores on the GRE predicts later grade point average. Then is a concurrent, which the results of the test are compared with other test results or behaviors at or about the same time. Highlight at or about the same time. Concurrent. current, current, what is happening currently at or about the same time. Okay, we're gonna look for keywords. That's how you get your answers. And then construct. How is it constructed, right? The extent it measures some hypothetical construct. In construct validity, you're going to see convergent validation and discriminant validation. All of that means is it a high correlation or is it no correlation? Is there a high relationship or there's no relationship? In the constructs, that's it. And it should be criterion once I think. Oh, that was under criterion. Now, when I studied this right here, this predictive will be criterion validity, okay? I like how they put this there because I seen a practice question and it was asking me like predictive. And if I would have known that criterion went that way, I would have got that right on a practice test. Now I know, think about criterion tests. When you're thinking of a criterion test, I always think of classroom tests. What I taught you, you take the test. I'm predicting you're going to do well because I know I'm a damn good teacher. That's all. Right? Well, I was a good teacher. Now I'm not a teacher no more, but yeah. We all good with that? Moving on. Tests may be reliable, but not valid, right? A scale can tell you weigh 2 pounds every single day, but I'm pretty sure I weigh way more than that. Okay. But a valid test are reliable. A test that is valid have to have reliability. Okay. Remember VAR. Valid, always reliable. Valid, always reliable. Oh, yeah, thank you. See, Toya, I'm telling you, she on it. That's my girl. All the things are in the chat, guys. All right, test may be a power test. What's a power test?
Something you have to power through. It's not, it gave you a lot of time, no, like complete
No
amount of
time.
time, no time or a whole lot of time.
Mm-hmm. The NCE is a power test. It give us time, but it give us a good amount of time.
Mm-hmm.
However, the power part is saying, how much do you know? How much can you power through this test accurately? Then there's the speed test. What's the speed test?
It's timed and you most likely will not finish. It's made so that by the time of the test is finished, you have not, you haven't completed the
Yeah.
test. It's
Think
as
of
much
a
as you
type.
can know in that amount of time, trying to get as much
Yes.
down in that amount of time.
Think of a typing test. You remember we used to have to type and get your words per minute? That's a speed test. How fast you can get them. How fast you can get them. And it never ends. And you're like, all right, I'm done. My fingers hurt. Okay. Then there's assessments that may be norm reference. What's a norm reference test? When I think of norm reference test, I always think about state testing for school, for kiddos, their state tests, because that norm reference test is trying to see the norm of that grade nationally. So everybody in that same grade around the world is being compared by their age and their grade. It's norm reference. Is it normal to this age and grade? All right. Like I said, criterion, always think of classroom test. You learn something, now you're about to test on it, right? It's predetermined criteria. I mean, yeah. And it compares individual performance to a predetermined criterion. like the National Counselor Exam cutoff score. Dang, it's always pulling up. Then an ipsative test. An ipsative test is, I heard, I versus me. That is only your scores being compared to your scores. That is your test being compared to the test that you did before. That is your score seeing how better you did than the last time you took this test. Okay? I versus me. Then I will highlight maximum oops, moving a little too quick. Maximum performance test, just highlight best performance. Typical performance test, just highlight may occur on an interest or personality test. Just straight up definitions here. Here's the purpose and rationale for using tests. Because why? It helps the counselor decide if the client needs are within the range of his or her services. Because if you're not trained to do it, don't do it. If it is not in your scope of practice, don't do it. We're going to refer, and in the contents of ethics, we are going to do benevolence and make sure the well-being of this client is met and mastered, and we're going to make sure they get there every step of the way. Okay? Help the client gain self-understanding. Why am I going through what I'm going through? Help the counselor gain a better understanding of the client. And then assessing the counselor in determining which counseling method, approaches, and techniques would be suitable. Assist the counseltee to predict future performance in education, training, or work. Help the counselee, whatever, make decisions about their educational or work futures. Help identify interests not previously known, and help evaluate the outcome. I will also highlight circumstances under the test that may be useful for placement, admission, diagnosis, counseling, educational planning, and evaluation. Also, licensure and certifications and self-understanding. Okay? What does it mean when it's a regression towards the mean? Let me make it very easy.
Isn't it kind of like the outliers? Is
It
that
is the outliers, but just take it pre and post test. That straight up means if I give a group a pre-test, 9 times out of 10, they're going to do better on the post test. Regression towards the mean, meaning they're doing better. That's all. Standardized, straight up means standardized, okay? For an example, standardized instruments are administered in a formal and structured procedure. For an example, when we go in to take the NCE, it is standardized around the world, okay? We all will go in, we all would get our handprint, we all would take a picture, we all have to give our ID,
Where you going, Smoke?
right? Standardized. Non-standardized assessments is non-formal. That's checklists, rating scales, things like that, that it's not that formal. It is the examples would be like checklists and rating scales. That's all you need to know. Then the test and inventories, there's intelligence test, okay? Most of the time when I was looking at this, all the intelligence tests and all the inventories and all of that, the word is actually in it, so you know what it is, right? So look at the intelligence test. You got the Stafford-Binet intelligence scale. And remember, Stafford-Binet intelligence test, the mean is 100 and the standard deviation is 16, just so you know. The Wessler adult intelligence test, for all the Wessler tests, The mean is 100 and the standard deviation is 15. Also, it has been said that the Wechsler's intelligence test was really good and geared toward adults. That's what it was known for, just in case some facts coming through. Remember, there's the WAIS, WISC, and WIPSI for intelligence scales. There's the children, adults, and preschool. Always remember that one. The WIPSI is PP because the preschoolers always PP on themselves. And you know, that's the little babies. And when you're looking at the one for children, look at the C. And when you're looking for the one for adults, there is an A. That's how you're gonna tell those apart.
And the age groups for those, the adult one, it actually started at 17. Is that right or no?
It would be 17, yes, but most likely 16 to
16.
90. 16 to 90. No,
Oh,
lying. I'm lying. Hold on.
You is right.
So, yeah, 16 to 90 because it's going to be 6 to 16 for children. Yes, I'm right. And for the little kiddos, it's going to be 2 to 6. And for adults, 16 to 90. Specialized ability test, battery for children, Kaufman. All of these, the ACA, the SAT, the ACT, the GRE, the MAT, predicting futures, okay? Achievement tests. Look, the names are kind of in them, so you'll know what they are. Except for this Iowa test of basic skills, but I kind of finished that. Specialized achievement tests. GED, College Board Advanced Placement Program. CLEP. Aptitude test. Remember, that's just measuring future, your potential. ASVAT. Will you be good in the Army? How good is your science and math? Because if it's really good and you have really good abilities, you might can be a sniper. I don't know. Just saying. Abilities test here, CAPS. The DAT, aptitude. The names are in it. Just read it. Personality. And then your projective tests. Who use these two projective tests a lot? 3. Who use those a lot?
which one did you ask for?
The rush shot, the TAT, and the Rotter incomplete.
Ann Rowe.
And Rowe used rush shot. And who else used projective? And who she was a follower of some unconscious things. There you go. Freud. And then draw a person test is really drawing a person, which I would fail that test big time. Inventories, the MMPI, which can be a personality, but inventories too, CPI. The neo-personality inventory, the Beck depression inventory, Myers-Briggs type indicator. Specialized. This is for blind people. This is for deaf people, this one. This thing doing the most. Okay, then interests, inventories. Who did the self-directed search? And careers.
Holland?
Who?
Is that Holland?
Holland, yes. Strong interest inventory.
That's Holland too, right?
And career assessment inventory. Here, right here.
Holland.
I can't hear. What'd she say? Holland?
Yeah. Did you say all three of those were Holland?
Yes.
Okay.
Well, I'm thinking the career assessment inventory was by somebody else. I'm not sure. I know self-directed and strong interest. Who know the career assessment inventory? It was in careers. For somatic differential, literally, it looks just like this. So when you see something like this, you know exactly what it is. That's all. Okay. Intrusive versus obtrusive. Intrusive literally mean intruder. That's how I remember it. That means that the participant knows that they are being watched. Intruder. You are intruding in my space, but I know you watching me. So just because the intrusive, I know you watching me, the unobtrusive is without change, is I'm not aware that you're watching me. Okay. These are just some observation appraisal techniques. Where did we see sociometry? Where else did you see that? Sociograms. Where else
Oh,
was that?
groups. Is that groups?
That
Group.
is in groups. That is in groups. So that's in there. A figure or map showing that interrelationships are structure of groups. And the creator of this would be Jacob Moreno, father of psychodrama, who coined the term psychodrama. Him and his wife, actually. I'm sorry, my computer tripping off. Okay. I think that no, I'm gonna pass this up. You can look at the 29 if you really want to. I don't think it was great. Grade and age equivalency, equivalent scores. That just basically saying the 8-year-old score should be on an 8-year-old reading level, if you will. The age and the score should be equivalent. Percentile ranks just mean a percentile rank of 35 means that the individual score is higher than 34% of individuals in that norm group. And then on the other hand, 65% of individuals scored higher than that kiddo. So highlight that, please. Then computer-based assessments, it just talk about the advantages of it and the disadvantage of it. Okay. Taking tests on the computer, some advantages, standardized administration and scoring. Feedback and results may be available immediately. Assuming computers are available, the cost will be reduced. And profiles of results and reports can be generated. Some of the disadvantages are not all assessments are available on a computer. So some of them might still be pen and paper. Like the Westler, that's still pen and paper. Like that's not on the computer, not yet. I watched my diag do it at school, and she's still doing pencil and paper to get it. Testing by computer may be scary to some people. Think of those older people. Technology scare older people. Heck, they scare me a little bit. If not available, computer equipment can be very expensive, and personal contact with a test administrator or proctor may not be available. So those are the disadvantages. And of course, we know when we're talking about ethic issues, you got to make sure the test is not biased because it could be biased. It might not be normed on that population of people who's going to test. Counselors have to be trained and competent to select and administrate tests. So highlight that. You have to be trained. You can't just be in there just giving tests. You have to be trained on this test. You have to take test security training to make sure you know how to make sure it is secured and everything, okay? Test results should be released only to the competent professional and with the consent of the test taker, okay? Tests may be used to label and stereotype, and it can invade people's privacy. Confidentiality of test results may be an issue, especially if it's computerized. And then computerized testing online may raise the issue of validity. And if test is given, the results should be interpreted because the test actually belongs to the client, okay? Their scores belong to them. Their records belong to them. However, if that score is going to hurt them or like hinder them, because remember, non-malevolence, we're doing no harm, we can tell them you can do an ipsative kind of interpretation. Just give them their score compared to their own score. Do not give them a norm reference scored geared to other people. Okay? And then review the measurement and evaluation section of the ethical standards periodically. We're at the end, but hear me out. When you're looking to see what is the right test or measurement to use, you're going to refer to the mental measurement yearbook. Okay? In this yearbook, it is a critical review of tests and lists published reference of tests. And it lets you know what this test measure, who's it good for, who's it not good for. I wouldn't pull this test on this culture. I wouldn't do this. This is where you're going to refer to. Then this test in print. Highlight that 3,000 testing. It has 3,000 testing instruments. And then these are just some references that would be good to know. And knowing that these are a part of the division in the ACA. And that's it. It wasn't too bad, huh?
No. Go back and read it one more time.
I recorded it so you can go listen too.
Yeah.
Any questions? Anybody stuck?